All right, we're going to do some practice problems with temperature and conversions with area and volume and dosage calculations. So first we're going to do some temperature practicing, converting 32 degrees Fahrenheit to degrees Celsius. So remember, we're going to use Celsius is 5/9, F minus 32. So we do inside first. 5/9 times 0 is just 0. So this is 0 degrees Celsius. And remember, with all of our practice problems, you should really try them first and then come check out and see how you're doing. Part B, again, we're transferring to degrees Celsius. So we would take Celsius is 5/9, the degrees they give us minus 32. We work inside, so 5/9 times 180. And when I do that math, I end up with 100 degrees Celsius. All right, let's do a practice of going the other direction. C, convert 0 degrees Celsius to Fahrenheit. So now I have Fahrenheit equals 9/5 times the Celsius value of 0 plus 32. Well, anything times 0 is 0, so 0 plus 32 is just 32 degrees Fahrenheit. And letter D, we want to do 100 degrees, so 9/5 times 100 plus 32. We do the multiplication division first, so 9 divided by 5 times 100 is 180, plus 32 gives me 212 degrees Fahrenheit. And you might say, well, I don't know why we did those first two and then those second two, we just undid them. Well, we did, and that's fine. But this shows us the importance of these values. 32 degrees Fahrenheit and 0 degrees Celsius is the freezing point of water. And 200 degrees Fahrenheit and 100 degrees Celsius is the boiling point of water. So that's why those are important. All right, let's just do a general one. You need to cook a roast at 350 degrees Fahrenheit. What is this setting in Celsius? So, Celsius is 5/9 times the Fahrenheit they give us minus 32. Work inside parentheses. So 5/9 times 318 gives us 176.67 degrees Celsius. So you always want to make sure you use the correct formula. Whatever they give you should be in the meat of the problem. Number 3, how many square centimeters are in 1 square foot? Well, 1 square foot. Square means 2. Well, we can't go from centimeters to feet. We can go from centimeters to inches and inches to feet. So my first step is going to be to say, well, I know that 1 foot is 12 inches. And because this is squared, I'm going to do that twice. 1 foot, 2 foot, cancels out the squared. Then once I have the inches, then I can say I know that 1 inch is 2.54 centimeters. And again, I do that twice because there are 2 of them. 1 inch, 2 inch, 1 inch, 2 inch. All of these numbers are in the numerator, so I multiply, and I end up with 929.0304 square centimeters. And it's squared because there are 2 of them. Number 4. A greenhouse is 20 feet long, 15 feet long, and 10 feet high. One of those is probably supposed to be wide. Let's make that wide. 15 feet wide, 10 feet high. What is the volume in cubic feet? Well, volume is length times width times height. So 20 times 15 times 10 gives me 3,000 cubic feet. And it's cubic because there it's 3. So what is this volume in cubic meters? Well, if I have 3,000 cubic feet, I'm like, well, I can't go feet to meters. I can go yards to meters. So that means I first have to go feet to yards. So 3 feet is 1 yard. This is cubic feet, so that means I have to do this 3 times. So 1 foot, 2 foot, 3 foot, go. All right, so now that I'm in cubic yards, now I can go to cubic meters. So 1 yard is 0.9144 meters. 1 yard is 0.9144 meters. 3 times 9144 meters is 1 yard. So then 1 yard, 2 yard, 3 yard. They all cancel out. So you divide by the 3's because they're in the bottom, multiply by the 0.9144 because they're in the top, and that gives us an 84.95 cubic meters, if I can read my handwriting correctly. A small city produces 500,000 cubic feet of garbage per week. If all this garbage were stacked neatly in a nice vertical pile on a 100-yard by 60-yard football field, how high would the pile be in feet? Now, if you think about this, okay, cubic feet, pile in feet. First thing we should do is change these to feet. So 100 yards, 1 yard is 3 feet. So we're going to multiply by 3. So 100 yards is 300 feet. 60 yards is 180 feet. Okay, so to find out volume, we take length times width times height, and that gives me volume. Well, we have the length, we have the width, height is unknown, and here is the volume. So we have a formula here, 300 times 180 times an unknown value, let's call it h for height, equals 500,000. Now in solving this, first let's multiply these two numbers together to make this a little bit easier. 300 times 180 is 54,000. So 54,000 times h equals 500,000. In order to get h by itself, we divide by the number in front of it, which happens to be 54,000. That means h equals 9.26 feet. So if we would put this 500,000 cubic foot of garbage on this football field that's 100 by 60 yards, it would be 9.26 feet high. That's a lot of garbage per week. That's every week. Number 6, a soda can measures 12 centimeters high and has a radius of 3 centimeters. About how many milliliters of liquid will it hold? Well, let's see what I know. I know I have a soda can, which is cylindrical in shape. It's 12 centimeters high. The radius, which is half of the circle, is 3 centimeters. So volume, because how much liquid will it hold? Well, volume is pi times the radius squared times height. So 3.14 times 3 squared times 12. The volume in cubic centimeters of this soda can is 339.12 cubic centimeters. Now, hopefully you recall that we have a conversion that says 1 cubic centimeter is 1 milliliter. So those cancel out, and I'm just left with 339.12 milliliters. Boom. And that is how many milliliters that liquid can hold. Number 7, the speed of light is big, meters per second. How many miles per hour is this? Okay, so this is some big numbers here, but that's all right, we can work with this. So I have 299,792,458 meters per second. And our goal is miles per hour. And I'm going to have to move that because I'm going to run out of room. So the first thing I'm going to do is I'm going to change meters to miles. Now, I can't just jump straight meters to miles, but I can go meters to kilometers, right? But then I can go kilometers to miles. So to go from meters to kilometers, recall that we will go left 3 places. So this really gives me I don't know why I put that point there, 299,792.458 kilometers per second. Now I can use my conversion. 1.6093 kilometers is 1 mile, and that gets me in miles and causes my kilometers to go away. Now to go to seconds, or to get out of seconds, I know there are 60 seconds in 1 minute, so that makes my seconds go away. And then I can say there are 60 minutes in 1 hour. There's my hours. So now I'm in the right units. My minutes will go away. So I take my big number, I divide by the 1.6 crap in the bottom, multiply by 60, and I end up with a huge number. 670,616,629, nope, 620, oh, I'm looking at the wrong thing. 634,964.8 miles per hour. I did this 2 different ways just for fun to see how close the answers were, and they were actually off quite a bit. But this is going from meters to kilometers. If you do meters to yards to feet to miles, it's actually a little bit, quite a bit different, about about 18,000 difference in terms of miles per hour. So, yeah, just FYI. Number 8, a swimming pool is being filled at the rate of 15 pints per minute. So 15 pints per minute. We want to know that in gallons per hour. So if I want to go pints to gallons, I know that there are 2 pints in a quart, and I know there are 4 quarts in 1 gallon. So pints cancels out with pints, quarts cancels out with quarts, gallon is taken care of. And then to go minutes to hours, 60 minutes is 1 hour. Minutes, I have hours in the bottom just like I want, so my units are good. I multiply on the top, divide on the bottom, and end up with 112.5 gallon per hour. So it's really, again, remember, you're starting with what you have, and you're kind of letting that dictate where you go next. Pints to quarts, quarts to gallons, get you where you need to be. Number 9, you plan to take a 400-mile trip and figure you can average 60 miles per hour. How long will it take you to make the drive? How long? We're looking for a final answer in hours. So if I can go 400 miles and average 60 miles per 1 hour, that makes my miles cancel out. I'm left with hours. That's what I want. 400 divided by 60, it'll take me 6.67 hours to make that trip. So hopefully, you can average that the whole way. Number 10, a certain drug dosage calls for 25 milligrams per kilogram per day, and it is divided into 2 doses, 1 dose every 12 hours. If a person weighs 250 pounds, how much of the drug should they get in each dose? Well, 25 milligrams per kilogram, you start in 250 pounds. So your first step is to take the 250 pounds and change that to kilograms. So recall that 1 pound is 0.4536 kilograms. That gets me out of pounds into kilograms. Then we can use the 25 milligrams per 1 kilogram. This now will give us the total milligram dosage. So roughly 2,835, this is the total milligrams. Well, it says each dose, and there are 2 doses. So divide this by 2, and the person is going to get 1,417.5 milligrams per dose. And that right there is the dosage issue there. All right, let's go to number 11, the last one for this video. If a drug has a concentration of 400 milligrams per 10 milliliter, 400 milligrams per 10 milliliter. How many milliliter? Well, milliliters are on the bottom. I don't know. How many milliliter are needed to give 1.5 grams? Now, I set up this proportion, but there should be like fires going off in your head because I've got milligrams and grams. Those are not the same. So I'm going to change milligrams to grams. So milligrams to grams means I'm going to go left 4 places. So here's my, why did I put 4? It should just be 3. Oh, goodness. I need to go to sleep. It needs to go left 3 places. Milligrams to grams is left 3 places. 1, 2, 3. So this is really 0.4 grams to 10 milliliters as 1.5 grams is to how many milliliters? Now I can solve this proportion. I'm going to rewrite it again without all of these, the labels, because now that the labels gram, gram, milliliter, milliliter, now that they match, I don't need to do anything else. So I can do 0.4 over 10 equals 1.5 over x. And I'm ready to cross multiply. So 0.4x equals 15. We divide both sides by 0.4, right, the number in front of x, and it will take, 37.5 milliliters to go with the 1.5 grams of the drug.